Okay, so circle. So the center of the circle is the center. And sometimes what they'll do is they'll give that a point. So you know what I'm going to do? I'm going to actually erase that. That's why we're working in pencil, right? And we're going to call it point O. Hey, Hayden, if you wanted to move up, you're welcome to. You're a long ways away back there. I even forget you're there. And this center point is part of naming the circle. And when we put a dot with a ring around it and make that the size of a letter, the name of this circle is circle O, because it has a center point O. If I named that center point L, we call it circle L. And so this is red circle. Circle O. And that's the center. So then the definition of a circle is a set of points that are all a certain distance from the center, and that distance is called the radius. So all of these points out here that we drew with a line, a curved line, that constitutes the circle. This is the circle, not the middle of it. Just all these points out here that make this line. And those points are all the exact same distance away from the center. We call that the radius. So I'm going to write a circle. Here's a set of points. So all the same distance. And then say parentheses, radius. From its center. So a circle is a set of all the points that are the same distance, called the radius, from the center. That's a circle. So that does all kinds of things. Here's a point. I'm going to call this point M. There's another point N. So what happens is that, M and N are on the circle, so we know that both of these distances from the center are exactly the same, and we call that a radius. Sounds kind of formal, right? Yeah, it is kind of formal. We're making things more and more formal. Because with geometry, it's really all about definitions. And we use definitions in geometry to describe things very precisely. So this is a radius. Here's another radius. So what's it called when we go all the way across? So like if I'm going to call that point L. This is a diameter, yeah. So here, segment LM. You can say that's a diameter. So what's the relationship between how long the diameter is and how long the radius is? Yeah, times 2 for the radius makes the diameter. So diameter equals 2 times the radius. And we can abbreviate that, right? D for diameter, and 2R, twice the radius. Tell me if I'm going too fast. Okay. Then, we just went from we went along the circle from N to M or M to N. That's called an arc. ARC. There's lots of arcs here. You know, there's L to N, that's an arc. L to M is an arc. M to L. You could go M to, see, like if you did all the way around beyond 180 degrees, then you would go M, L, N. That's a different arc than NM. Okay. What's plural of radius?
Radii.
Radii, yeah. Yeah, so radii.
Why is it?
Huh?
Why do they do double I?
So it's not radii,
I guess so.
That'd be cool though.
it's radii. It's Latin. First I is an E, second I is an I. Okay. So that, I think, we got a little bit more. So if we talk about the area within a circle, you know, like you come up with an area, it's got 2 dimensions to it. If you limit your area to just a small section like this, that's called a sector. It's a sector of a circle. So you could say, well, it's a half or a fourth or 23%. We use that when we make circle graphs and pie graphs. There's lots of other uses of it. One more thing is the circumference, which is the perimeter of a circle. And we spent time with this last year. This is an important one. So are we okay remembering that circumference is the perimeter of the circle? Yeah, it's the distance around. So circumference gets abbreviated with C, capital C. Do any of you remember how to figure out how far it is around a circle? The formula for the circumference of a circle.
Is it a diameter times circumference?
Yeah, it's a diameter times pi. Yeah. So, that's a formula we kind of need to remember. And 3.14 is an estimate. Yeah, so you guys, some of you said 3.14 times the diameter. That's an estimate. If you use pi, that's exact. And I'll show you how that works. We did that a little bit last year, but I'll bring it up again and show it to you when we do some circumference and area things. The difference between exact and estimating. Anytime you put in a 3.14 and you do the arithmetic, that's an estimate. Because pi is irrational. Its place values go forever. There's no end to it, which is kind of a weird concept. Hard to grasp. Phoenix.
So that, wait. So then you wouldn't put the squiggly equal sign because it's exact.
Right. Squiggly equal sign is when you stick a 3.14 or 3 or something like that in there and do the calculation. May I erase the circle?
Yeah.
Okay. So they go and they give us an example like this.
That's it.
It's said to be a cylinder.
Okay.
Cylinder's got a height, and they want to know what the circumference of this can is. So we want to use circumference is equal to pi times the diameter. I don't know what they do in the book. They probably give us a real easy number to work with. Like, yeah, 6 inches. So they go all the way across, and they say what the diameter is with this one. Sometimes they'll just tell you what the radius is, and then don't forget you have to double it to get the diameter. So in this case here, if we're going to be really formal about our work, we start out with the formula, circumference is equal to pi times d, and then it'd be pi times 6 inches, don't forget to include the units. And this right here is exact, but nobody talks like that. Exact numbers are just used for more and more math calculations. Nobody's going to walk up to you and say, oh, well, that was 6 pi inches. Except maybe me, I don't know. So what we want to do is since this is a real object, we want to take it to an estimate. So then we can, you're right, Phoenix, we use the squiggly equals, which is about equal to. What is that? If you did 3.14, how much is that?
That would be 18.85. 4. 18.84.
Maybe you just say 19 inches, right? And you read it, it's about 19 inches. That squiggle's not too good. Yeah. It's not that great. Simple enough? Straightforward? Okay. You got a drawing compass, right? Drawing. Ooh, shoot.
Do you want me to pass stuff out for you?
Sure.
What you got?
What should we have?
2, 1?
One. And you don't have to worry about the circles on the other side. We want to use the clear side of the paper. Yeah. 3.14 is an estimate of pi. So pi goes 3.1415. It goes forever, it never ends. Yeah, it's never ending. Okay. So I'm going to work here, okay? You got a drawing compass? And do you guys have rulers? I know I gave you rulers at the beginning.
I actually brought one. You could have seen that.
Good. And I know I gave you like 8 of them the other day.
Yep.
So,
Lots or just me?
yeah, just you. So I'm going to have you draw or construct a circle that's got a radius of, gosh, can you do 10?
Inches?
No,
Centimeters.
Oh.
That's on the back side.
Centimeters.
10 centimeters for a diameter.
Yeah, we can do that.
Yeah, don't worry about your circles. Those are for something else in another class, geometry. So this can be right in the middle of your paper almost. Yeah, it's going to be really close.
My car's close enough.
I'm going around more than once so that you can see the line a little bit better, but you don't need to. And then, when you do this, would you make sure you mark the center? At least get a dot in the center of this thing. And then take your ruler, and I'd like you to draw a diameter. And if you put your pencil right on that little dot and then push the ruler up against it,
How do I know the strength?
you're using a ruler, right?
It's kind of like,
Yeah, but does it have to be directly vertical?
No. You can have yours like that, doesn't matter. Any diameter, just draw a diameter. But you need a big long ruler that's gonna get all the way across. Ooh. What about the plastic one I gave you guys?
What?
Yeah, day 1 or day 2, I gave everybody a ruler, a protractor.
got a metal one.
Use the tiny one and you can extend it, yeah. Okay, so now we've got 2 semicircles. And then either use a corner of a piece of paper or a protractor. Use something that's square. And set up another diameter. So your 2 diameters are perpendicular to one another. And the diameters can hang outside of the circle because we're going to cut this out anyway. Okay, so now everything's 90 degrees, yes? Okay, what's half of 90? 45. So now you need to come up with 45-degree angle diagonals. You got to put in 2 more. That's harder, isn't it? That might require your protractor.
We don't have those anymore.
Why not?
I think we finished with them and we took them back.
No way. Didn't I leave you with your protractors?
Yeah, you left us with all our materials.
Yeah, I'd love to with everything. Quite certain. The question is whether you've left them somewhere else or not.
Wait, so I'm supposed to do another 45 degrees?
Yeah, so you want to have 8 pie pieces. And then, of course, what's half of 45?
22 and a half.
22 and a half. And if you want, you can kind of eyeball that one.
Yeah.
As long as you have a pretty good estimate. Yeah. So what do you have? 2, 4, 6, 16 pieces, yes?
No.
This is what's always fun. Where does the scissors go?
Wait, how much is that?
Someone took the scissors and now I don't have them.
There's brown ones up there.
Yeah, there's one.
Are they, do you want me to run up to the middle school and grab them?
Wait, hey, how much is that?
The ones that are in there?
Yeah,
I
I
can go
guess.
check. I'll go check for you.
Unless I'm just missing them here.
Close. Let me go grab something for you.
Do any of you guys have scissors in your box?
No.
I have scissors right here.
I have scissors.
Or
in my
scissors
pocket.
right here?
I have scissors in my pocket.
We're walking with and trying to help you right now.
Somehow my boxes are places. Do you? You want to ask for somebody else? Here's another. Hey, behind you, those purple mini boxes, yeah?
That's the clock. I can't remember the clock.
It's a very dark line.
Good choice.
Yeah, that's what it is.
Nick.
Nick, yeah.
Nick Wild, the
trouble now.
Look up Nick Wild one. Bad idea. I'm not gonna lie.
So now we have to do half.
Why did you
Huh? I didn't look up.
do that?
You have recorded a bunch of stuff that don't look up.
How do
You did not, like, not even halfway there yet.
That's not part of this stuff.
Did I get it? I don't know.
Did you do it? Is what you say?
I don't even know.
You have lots of scissors back there?
I got the best.
All right. The scissors that we have, can we share them? Okay, can you cut your circle out? And then cut it into 4 equal sectors?
No.
Yes. I'm sorry, I texted you that I found them. Oh my God, I looking at all the boxes and the other one. Thanks.
You're welcome. My phone's here.
Oh, okay. Yeah, I kinda figured. So who else wants the scissors? I got more. Who wants better scissors? I have better ones.
I took them from Mr. Baumgartner though, so we have to make sure we give them all back.
These are all mine.
Well, he took them from you, they were in his room, and then I stole them from him,
Well,
with permission.
So
Okay, I cut it out. Alright, what are we doing?
taking them back. Those are not great scissors, are they?
Did the shears?
These are like dangerous. Anybody else?
Oh, okay.
Shears?
Alright,
I need a ruler.
thank you.
Straight edge of your book. The books are in pretty good shape. Here's a better scissors if anybody wants this one. Okay. This is not a Miss Miller contest, okay? If you have something that roughly resembles a circle when we're done cutting out the circle,
Like a jelly bean?
you will be doing fine.
What if we cut a jelly bean like Bubby said?
A what?
A jelly bean.
A jelly bean? No, we're not doing any lips. But if you have some jelly beans, break them out. Jelly beans would make you edgy? What do you need, better scissors? Longer ruler.
No, just in a quarter.
Yep, 4 even-sized sectors.
I feel like I should
Oh, I forgot one.
I think that's, yeah, fine. I mean,
I know, mother like, oh,
There we go. See, are you cutting them out into 4 equal sectors?
Yes.
Quarters, yes?
Yes.
Quarters.
Ooh, they look like mini fans.
They do, that's what we're building today.
Okay, good. This is like the most painful thing in the world.
Skills, there you go. So straight across, cuts it in half, cut each of those halves in half again. Careful, just quarters for now. Have we done this before?
We did this like the first week when we put it up, and then I remember having to cut out all the tiny little pieces, put them together. It took a long time.
So I should just bring up that video, huh? Just go ahead, grab a cup of coffee.
Not even, okay?
Come on, come here. Here we go. Cut out one of those.
Oh, what? Yours cut? I can't even tell because they're so perfect. If you cut them over time.
Okay, do you see how I laid it out underneath the camera up there? Now we get to check your COVID memories. Because I'm told that we did this like on day 2 of COVID school last spring.
Yeah. We did something like this.
This circle was a lot smaller, so it was a lot harder.
Yeah.
We were trying to circle and cut it out, and we let them all out.
Are you gonna need this?
Yeah, they're gonna keep cutting with them. You gotta cut all the sectors down. All right, could I have you guys focus up here, please? Okay. Right. Okay. So does that shape resemble a parallelogram? No, parallelogram.
Yeah, Chap doesn't.
Here's a diagonal, and then across the top.
Oh.
Not
It's
very
curved.
well.
It's curved.
It's not very good, is it?
I did, but I
Maybe if you were like really bad at drawing.
So what I'm trying to do, I don't know, it hardly even wants to fit on here. What I'm trying to say is that this edge here is parallel to this edge, and then across the top is parallel to across here. But the problem is you got curves. So cut it into eighths. So cut each of these in half. Sectors, scissors.
Yes.
So now cut them into eighths.
What? Cut him again.
Is that getting too close to you? You're reaching over and
My bubble.
in your bubble. Sorry.
It's okay.
Okay.
I haven't been hugged in like a year, so, because of COVID, so.
Really?
I'm not used to having people around me. Archie hugs, well, no, that's not, Archie hugs me every day.
Oh, hugs are safe, just not face to face.
Not face to face.
CDC went and changed that.
What they do.
And when they said it's not, but if you go to the universities that are actually doing the research, they say that the CDC has become questionable in their reliability at times. Okay, there we go. Look at that.
That's very good.
I mean, yes, it's very, very. You realize that all of your talking about brownies has to do with you're strong. Keep in mind.
But it takes 2 days.
Wait, like,
Getting the vaccine right on the first try? I don't know. They know. It was pretty high probability. They were up in the neighborhood of a 95% probability that it was correct. It wasn't 100%. Nothing's 100%. Anytime you get over 92, you can say it's clean, it's good statistically. Anytime you're over 85, you're probably going to be okay. But over 92.5% probability of it being the correct vaccine, we function and we assume that it is the correct. And both of these are over 92.5. And then Pfizer came in at 93 and then Moderna came in at 95. It's just a test every single possible human being, which is impossible. So we have to rely upon statistics.
And then see if it goes down.
Yeah.
From the group.
But we need more than what we have going right now. We only have 40% in the borough that have taken the vaccine, and we need to get up over 80.
Yeah.
Okay, you guys have it cut out, or we're waiting on you. You'll catch up. So I've got ants up here now. Does that look closer to a parallelogram? So you see these little curves, the little dipsy-doos? They kind of became smaller, didn't they? So we got two parallel ends here, and if you were to cut off, a little bit of the curve and fill it in, it's getting close, isn't it? So cut it in half again. Get yourself down to 16 sectors. And then try to organize it, if you can. This gets hard.
Just imagine.
How many times does he say that? They haven't released anything. Like, God's coming out right now. Chaos is ready. Have you read any of the manga? Wait, is the manga for Stranger Things? No, we're talking about AI. Oh, I thought. Oh.
Yeah, no, it's on my next one.
Well, Hunter Hunter's long.
Yeah, no, I kind of
If you don't want to press on,
Supposed to watch Ghibli Studios movies. She doesn't like that.
Unless it's the book.
My neighbor's home.
My neighbor says anime.
Spirited Away was weird.
Anime was sus.
What was that other one? Spirit Trip? Something
You got them there, Brooklyn?
Huh?
You have them all cut out? You have them all arranged?
Yeah.
Wow.
Then there's also the
My
new.
list is long.
You kept up? You got them done as fast as I did? I've done this 20 times. All right.
Loading castles.
I don't know why I moved this thing. I just moved it dock last
Oh yeah, yeah. It's like my mom who does not understand.
I need to practice my drones with like
Honestly, my favorite one.
Jane named his son after what
Okay. gonna debug it.
Cool.
How are we doing? We getting them cut out?
Almost.
You're like a whole bunch of
yeah,
rectangles,
I got 'em
huh?
cut out. Me too.
Put them in order.
That is super interesting to me. You and like 3 other kids won't let them touch. Is there a reason why? Huh?
I don't like them touching.
Okay. No, it's just really interesting to me. I was wondering why. And they're very easy.
But I also don't like 1, 2, 3, 4. I don't like any of those numbers.
That's okay. It's interesting too because the space in between is exactly the same. And it's the same way with the other kid.
All right, we're done now. All right, here we go.
All right, go psyche, you know.
First of all, if I call that a parallelogram, what is the area of a parallelogram? Well, I heard several answers. I need one. Time. I need everyone up here, focused up here though. Okay, area of a parallelogram. Will it? Base times height.
Oh, no.
Right there. Okay, now, if we kept cutting these things for the rest of the day, and we made our sectors really, really thin, this edge right along here, in a parallelogram, it'd be this edge that's over on this angle here, right? But if we kept cutting and cutting and cutting, that parallelogram would get closer and closer and closer to what shape? It'd get closer to a rectangle, which has the area base times height, or length times width. But let's leave it at base times height. So now with this right here, before you cut this figure up, I feel like I'm in the Wizard of Oz. Every time I look away, the munchkins stick out from behind the bushes. My other end, I turn, I look at this, I hear all the whatever it is. I can't make munchkin noises, but you guys are doing a very good job of it.
Yeah.
No more. This edge here of that sector, where did that come from? The circle. And it is the same as the?
160 radius.
It's the radius. Orion, no more. I need you to be quiet because I can't concentrate when you're talking. Okay, so that radius, oops, I'm mixing these up. That's height, that's base. That radius is a lot like the height of a rectangle. So the radius in this circle can go back and forth with the height of the rectangle. That this is slowly becoming. But what about this base length? Is that the whole circumference? That's half of the circumference, and the other half of the circumference is across the top. So when we draw this out, I wish I could write on this board, but I can't. I guess I can write it around here, can't I? This is like half of the circumference. What's the formula for circumference? Pi times the diameter. What's the diameter equal to?
2 radius.
Twice the radius. Okay, but now, this base here is half of the circumference. And the circumference is equal to pi times 2r. So I could say 1/2 times pi times 2r instead of half of c. So this base here of this rectangle shape is like saying half of pi times twice the radius. So what we're doing is we're making this almost rectangle shape that has a height which is equal to the radius. And then this base is 1/2 times pi times 2 times radius. What's 1/2 times 2? 1. So this is just pi times radius. That's what this is, because we cancel out the 1/2 and 2. So across here is pi times the radius. So this is what I've been drawing on the whiteboard. So the area is the height times the base. And what is that? R times pi. What's r times r? What's another way of writing that?
2r, 2r.
Not 2 times r, but
2r.
r to the second power. And we put pi in front of it, because we can multiply in any order we want. So the area of your circle is pi r squared. In your little construction in front of you is as close as we can get to proving that formula.
Wait, so would you do pi times r and then do that in a second, or do you?
What's the order of operations?
Yeah.
Exponents and then multiplication. So, if we had a circle here, it's not times 2, it's times itself. Times itself. We cannot go and say it's times 2. Then we'd write 2r. You see, this is not equal to that. Those are not the same. If they were, there'd be no reason to write this. You just write everything like that. But they're not the same. Okay, so if, for example, we said that the radius was 6 inches, well, wait, what was your radius? What did you guys make?
10 centimeters.
Was 10 the radius?
Yeah.
Okay. This is all you need to know. All you need to know is the radius of a circle, and then you can calculate its area. So your work would look like this. Area is equal to pi r squared. Rewrite it pi times 10 squared. What's 10 squared? 100. So then we most commonly will write pi after a number. If you don't, you need to have a multiplication dot. Hayden, you up here? See, that's why I want you closer next time. Okay, next time. So this is exact. And then we need centimeters. So this is interesting here. This is really 10 centimeters squared. So it's 10 times 10, and centimeters times centimeters. So then this becomes centimeters squared. Now, that's exact, isn't it? Because it is using pi. But if we were going to make a measurement and communicate that like in a real number, we'd say about equal to 3.14. So that'd be about 314. square centimeters. I can't write.
Do these calculators have pi?
Yeah, they have pi over on the right. It's a second function. But again, there's a limited number of place values that the calculator can display.
Would you do, you know how the square,
Say again?
so for the area of about 314 centimeters squared, could
Yeah.
you, get rid of the square and times it by itself?
No, because what's happening here is we're saying that this is equal to squares which measure 1 by 1 centimeter. That'd be the definition of a square centimeter. So if you could, you would say that there's about 314 of these in here. But because of the curves, you can't be exact. The only way you can be exact is if you talk about pi. Include that in your answer. So that took a while, but that's okay. So then the big question is, how much of this do I actually want you to do? Probably not all of it. So we might slow down a little here.
How many ones is
Can I do
Let me look at what I got. So I'm changing what I have online for your assignment. Do this, page 467. .467. Do 1 through 10. But read carefully. Are they asking for area or are they asking for circumference? And keep the two formulas straight. So page 450, 467, 1 through 10. No, they're not going to need anything except a pencil and their book. Yep, just numbers 1 through 10. And then we'll do some of the work in class tomorrow. We'll work together.